Good morning, everyone. Welcome. My name is Nathan, and you've registered for this training on charge, discharge, and state of charge. Give me 1 second, let me turn off this light. Make my video a little bit better for you. So I'm a trainer here with Simplify Power, and we're going to be starting this NABCEP approved training on charge, discharge, and the state of charge for batteries. And I'm delaying a little bit as the numbers are keep increasing here as people trickle in. If you are here for NABCEP credits, please stay till the very end of the presentation. I'll be providing an email address, and you can email me your name as you would like it to appear on your NABCEP certificate, and I will email that certificate to you. So I'll explain that at the very end. If you have questions, this is a webinar. I don't have the ability to unmute you, but what I can do is answer in the Q&A. So if you have questions, please drop them into the Q&A, which should appear somewhere on your screen near the menu. Let's go ahead and get started. So again, this is an opportunity for learning, and I'm curious if those of you that are NABCEP certified, my colleague Daniel and I will both be giving trainings at NABCEP. I wanted to introduce to you 2 sites. You're going to get copies of these slides after this training. If you're interested in additional trainings, we have training opportunities with Briggs Stratton's Power Academy, and that will be linked in these slides that I send to you. Additionally, we have more trainings that are coming up. If you look on our website, you can see that there's a calendar. If you look at the very top of Simplify Power's website, there's a training calendar, and you're in charge, discharge, and state of charge. All of these courses that we offer give you free NABCEP credits. And so if you're interested in these classes, please check both of these opportunities out. Looks like there was a question from Kuno. It says, can you explain how 3 new Simplify 24 3.8s right out of the package can show 26.1 volts after connecting and programming the set points? Is asking about what percentage state of charge they are. And so I will talk about state of charge here at the end, but let's get into the content first, and then I'll explain. So these are 24-volt batteries. I'm assuming if they're at 26 volts, because that's what you've specified. And so yes, 26.1 volts. We'll get into that, and hopefully you'll understand once we go through this. So thank you for the question, Kuno. I don't want to evade. Let's wait till we get into the content though, and then hopefully we'll all have an understanding. So I did want to point out what I've got on the screen here, this Learn Blue Volt, Learn Briggs. That link allows you to take classes at your own pace. And so you don't need to show up at a scheduled time like this live class right now. So as I mentioned, my colleague Daniel and I will be at the NABCEP conference if you happen to be there in St. Charles, Missouri, St. Louis next week. And so we'll be giving trainings there. I also want to point out that currently until March 31st, Simplify/Briggs Stratton is offering a $1,000 sign-up bonus for people that sign up as authorized installers and complete a 1-hour training course. So it's a pretty low bar for getting a $1,000 sign-up bonus. It does include you have to do 1 install with our product before June, the end of June, and you get $1,000 off. So no real conditions on that install. It can be pretty small. I'm going to get into just a little bit of our company and our philosophy. All of Simplify's batteries, now part of Briggs Stratton, all of our batteries are based on safe LFP chemistry. So we don't use cobalt-based chemistries, and you don't need to know everything about the different types of battery chemistry that are out there. But if you're installing home or RV-based storage, you really want to be going with cobalt-free LFP chemistry. It's the best thing on the market in terms of durability, reliability. It is a little bit heavier, so it's an iron cathode, and I'll talk about that in a little bit. So it's not suitable for things like ultra lightweight drones, etc. But it's a great chemistry for home and business power backup. Essentially, it eliminates the risk of unmitigated thermal runaway. It means that these batteries, if they are in an extreme temperature condition, don't run into a continuous chain reaction as the cobalt-based chemistries like NMC can do in terms of fire. We are a heavily tested and certified company, maybe the most tested battery company in America. We're producing our batteries here in Oxnard, California, and we go through all the regulatory and safety testing that we can. We are UL 1642, 1973, and 9540 certified, and those certifications are at the cell level, the battery module level, and then 9540 is a system level certification. We've gone through 9540 cell testing on all of our batteries, sorry, battery testing on all of our equipment. We also have UN Department of Transportation certification 3480, which allows us to ship. There are regulations around that, which determines how full the batteries, how charged the batteries can be when we ship them. And then 38.3 is a UN shipping regulation allowing us to airship batteries. We are proven. We've got a history dating back till 2010 using LFP and really improving intellectual property. In our early days, we had deployments with both the US Army and Marine Corps. We tested and proved another number of battery concepts for the US military. We've been deployed in over 45 countries with over 250 megawatt hours installed now. That number's gone up to over 300 megawatt hours now. And we really try to focus on simple solutions that do not take a long amount of time to install, and premium batteries. So given that we're doing a lot of our manufacturing and business here in California, we really are focused on the high-end batteries. We offer really strong warranties, 10-year unlimited number of cycle, 100% depth of discharge warranties that nobody else really can compare to. And you're backed by Briggs Stratton, a 110-year-old company, for your warranty, unlike some of the other cheaper option batteries. So it might not be the battery of choice for everybody, but again, this is kind of the timeline. We started as optimized energy storage and released our Liberty Pack batteries. These are mobile batteries that are good for film and broadcast or lots of different types of applications, such as maybe contractor use. But we released back in 2010, kind of hitting the film and broadcast industries. And then expanded into the military and residential use. We have mobile product lineup, and then we relaunched in Simplified Power in 2015. 2021, we were acquired by Briggs Stratton. We have continued to expand our product lineup as well, releasing a vertically integrated system, which consists of an inverter, energy track monitoring, and larger wall-mountable outdoor rated batteries. You might not know this, but we also have a high voltage and projects division as well. Again, we've got dealers around the world. We've been selling our batteries in many different countries. We're in 45 plus countries and expanding. As I said, we've got a full product lineup, and really what I'm going to be focusing on today, I'm a technical trainer, not a salesman, but I'm going to be focusing on the batteries here in the kind of the bottom screen and talking about charge and discharge and how to understand the state of charge, state of discharge, etc. Showing you what we have. This is our battery lineup. These are our battery boxes, cabinets. We call this the boss cabinets. And they can include an inverter built in, so you can really have a plug and play option. And on the right hand side is our newest release, our 5 kilowatt hour, 4.98 kilowatt hour batteries together with our inverter. These inverters pair well with Briggs & Stratton generators, and so we have standby generators as well as continuous use generators. Briggs & Stratton has a long history, and they were producing the engines for Generac back in the 1950s, and Generac and Briggs split up, and Briggs has their own separate lineup of generators, and now we have inverters and batteries that pair well with these generators. So let me get into Simplify's products a little bit. I want to talk just a little bit about chemistry. So I've got a whole background in chemistry. And I have a whole talk surrounding the chemistry and the way the batteries work. But there are lots of different types of lithium-ion chemistry. When people think of lithium-ion, they don't realize that there are many different types of lithium chemistries. So there's a different chemistry for a lithium-ion battery inside your phone compared to the chemistry inside a Tesla car and Powerwall, compared to what's inside our batteries. And we've been using LFP chemistry because it's the safest chemistry. If you're going to put these batteries in your home, you want them to be safe. So LFP battery chemistry, all these chemistries are different based on the cathode, the positive side of the battery. And so they're classified based on the cathode, with the exception of the last one, and I'll talk just a minute about that. So most of these chemistries include cobalt, and cobalt allows a little bit more energy density and a little bit reduction in weight. Our battery chemistry, lithium iron phosphate, lithium ferrophosphate is what the F stands for there, is based on an iron cathode. It makes it a little bit heavier, a little bit less density in the battery, but it's a lot safer. And it doesn't include cobalt, which cobalt is, a rare earth element. It's toxic. It's sourced in questionable practices many times in Africa, particularly the Congo. And I have spent some time there. My wife is from West Africa, and so I'm quite aware of the mining practices, at least in Ghana. And I've been to Congo as well. LTO battery chemistry is lithium titanate, and lithium titanate has a lot less energy density, but you can get extremely rapid charge and discharge characteristics out of lithium titanate cells. So we use LFP. It's the best choice for home batteries. You get the longest life cycle and the most safety. But chemistry is not the only thing. It's also form factor comes into play here. Form factor means the type of battery cells that make up your whole battery, your battery module. The battery cells are typically broken into 3 different types. Cylindrical cells. Cylindrical cells are kind of look like that AAA battery, that AA battery you've seen before. So you might have seen the 18650 cells. Those numbers just correspond to the dimensions of the cells. So 18650 cells, 18 millimeters wide by 65 millimeters tall, 65.0. Pouch cells are what typically occurs in cheap mobile applications. Some laptops are moving to this and phones are moving to these. They need to be protected though, because they're not very durable. They're easily punctured, and I'll show you an example of a bubbled out pouch cell. Pouch cells are the cheapest type of battery cell to make, lithium battery cell to make, but they're also the least durable. That has to do with the expansion and contraction of the battery as it heats up and cools down. Eventual movement of those layers causes these pouch cells to delaminate. Cylindrical cells are the most durable. They're also the most expensive, and they're really the top of the line cell. We use these in all of our batteries. So we have a premium cell manufacturer that we've been using for a long time. We've gotten better and better cylindrical cells that last a very long time, and that allows us to offer this kind of top of the line 100% depth of discharge 10-year warranty. Prismatic cells are also a decent choice for a home battery backup. They're more rigid, but they're plastic cased. Typically the cells are larger. They don't discharge quite as fast, and the reason for that is because these prismatic cells have longer pathways for the heat migration to get out. So the batteries typically can't be used to discharge and charge quite as fast as cylindrical cells. So for all those reasons, we use cylindrical cells in our batteries with LFP battery chemistry to make it the safest, most durable, long-lasting battery. We're expecting 10,000 cycles out of our batteries. So if you cycle once daily, that's 27 years. Right? Typically, by that amount of time, other factors might influence the battery. But even after 10 years, we're expecting 80%, or we're guaranteeing 80% of the original capacity and unlimited number of cycles, etc. So how are batteries made? Well, LFP battery cells only have voltages of 3.2 volts. So those are stacked together in packs that are both paralleled and then series. And so this is not an example of exactly what our battery looks like on the inside, but it shows you that you have to stack cells together in order to get up to the standard, which is now a 48-volt home battery system. So we offer batteries in different voltages, and the way we do that is by stacking batteries in series. And those batteries being stacked in series, those cells being stacked in series means that you have to have some type of control to maintain balance. And that type of control that maintains balance is the BMS inside the battery. And so we have a high performance BMS that has been manufactured for us here in Oxnard, California. It's top of the line BMS with communications, et cetera. And so I'm going to get into a little bit of the BMS. So I want to talk to you about the batteries we have available. For the most part, you're probably going to be most interested in the most popular of our batteries. It's a 48 volt, but I do want you to know we have small scale 12 volt batteries, 57 amp hour batteries. This is 730 kilowatt or 730 watt hours. It's our smallest battery that comes with connectors, and these are typically used for portable devices. We also have a 1.4 kilowatt hour battery. These batteries both come in 12 or 24 volts. They're small, decent for mobile applications. Typically, people will buy this 1.4 kilowatt hour battery for things like RVs, etc. Our larger batteries, we've got 5 batteries starting out at 3.8 kilowatt hours. These come in both 24 volt and 48 volt options. The rest of our batteries are all 48 volts. So this battery is great for drop-in lead acid replacements. You can use this battery to replace old battery banks. And if you're running a 24 volt inverter and equipment, this battery might be a good option for you. It can also surge. So this battery is capable of surging up to 80 amps per battery for 10 minutes. So that's a pretty high power output from this battery, over 3 kilowatts out of this battery. It's an 86-pound battery, and it does come with wall mounts. That bracket can be purchased from us to mount easily on the wall. It will also fit, that same bracket will also fit these Amplify battery. Amplify battery has a nominal voltage of 51.2 volts. That's a 48 volt battery. Nominal voltage means the voltage of the battery at a 50% state of charge. So at a 50% state of charge, the voltage will be 51.2. But classification wise, it's a 48 volt battery. The battery voltage will range from 48 volts all the way up to close to 54. This battery only comes in a 48 volt option. It's got advanced closed loop communications that allow this battery to talk with inverters. You can parallel up to 72 of these batteries, reaching 275 kilowatt hours. So kilowatt hours, that's the capacity of the battery. That's the battery's ability to hold charge, right? Most people don't realize that all batteries have both a power output rating as well as a capacity rating, and those two things are related. So the capacity of the battery is how much energy it can hold. The power output of the battery is how quickly it can release this energy. So this battery can produce a little over 3 kilowatts. This one will surge to 100 amps. This can produce 4.1 kilowatts of output power for only 10 minutes. But then it's rated at C/2, so just under 1.9 kilowatts for continuous output power per battery. Our batteries should only ever be run in parallel, by the way. We never use 224 volts in series to get to 48 volts or etc. They're always in parallel. That way the BMS can operate properly. This is a simplified battery. It's essentially 5 kilowatt hours. We came in just under 5 kilowatts because there are some regulations around sizing of batteries when you're putting them into a garage here in California. And so we want to make sure that we can come in just under that 10 kilowatt hour rating with 2 of these batteries. So this simplified battery, the nice thing about this, it's outdoor rated. It does come with a wall bracket, and it's easily just hung on a wall. This is a big battery. It's a 180-pound battery. You can hang it one person, but generally we hang it with 2 people. There are handles on the side to make it easy. All of our batteries have that kind of integrated circuit breaker that's there to both protect the battery and allow you to just turn the battery off when you're installing, etc. This battery is capable of 50 amps, 48.5 amps continuous charge and discharge. It can surge to 100 amps as well. And you can parallel up to 72 of these batteries, reaching 358 kilowatt hours, which is a huge battery installation. Most people wouldn't go that high typically, even though you could go up to 350 kilowatt hours for those batteries. You are really looking at a high voltage operation after that, and I can show you just a little bit of our high voltage batteries. We also include battery cases. These battery boxes are outdoor rated. They've got cooling fans built into the tops of the cabinets that are temperature controlled. These outdoor rated cabinets are a nice choice because they've got the combiner boxes already and include the bus bars for setup. We also have these battery cabinets. We call this our access cabinet that can be mounted directly, have an inverter mounted directly inside of it. Let's talk a little bit. I've been blasting through our products here, but I really want to get into the meat of the learning, and that's around charging and discharging of batteries. I think I'm going to go through this before I jump into the Q&A. I don't have anybody with me today to help me with the Q&A. But there are some notes on when charging a battery in cold temperature conditions. There's a challenge for the lithium as it migrates to get into the anode side, which is typically graphite. And so that process, as things just like something like a syrup would get very slow moving and viscous at low temperatures, the same thing happens inside a battery cell. And so at low temperatures, the lithium migrates much more slowly. So you have to be careful how quickly we charge and discharge a battery when temperatures get cold. This is not just true for our batteries, but for all lithium batteries, you have to be very careful when you're charging the batteries below 0 degrees Celsius. And there are also considerations on the discharge cycle as well. As you get below 0 degrees Celsius, you want to slow down that cycle. So before I jump into how temperature affects the charging and discharging, let's talk just a little bit about storage. So you might have a system that somebody has maybe at their summer camp or their winter cabin that gets turned off during some months. And so here are some temperature considerations for your reference. So if you're storing cells in the typical temperatures anywhere between 14 Fahrenheit and 77 Fahrenheit, or -10 to 25 if you're on the Celsius scale, you can store them for 6 months. And unlike lead acid batteries, which really rapidly charge and discharge, really rapidly discharge when they're stored, lithium batteries typically only lose about 1% state of charge per month. So they're going to stay charged up. I was at a facility in Florida where somebody had bought some batteries and they just had them sitting in a warehouse for a couple of years. We tested the state of charge and still after 2 years, they were at 92% state of charge. So lithium batteries maintain a charge a lot longer. If you want to safely store them, you can store them at 6 months within this temperature range. And if you're in a much more extreme temperature range, really low temperatures or really high temperatures, you can store them at 3 months without any kind of external consideration. So let's talk a little bit about the temperature range for charging and discharging of batteries. Our 5 batteries, these 12 volt and the 24 and the 48 volt option, don't really have advanced temperature monitoring in them. And so these are non-communicating batteries. So it's important that your inverter pay attention to the charge temperatures, especially so that if you get to really low temperatures or get to really high temperatures, you're not charging that battery. If you are charging in really low temperatures, you want that inverter or charge controller to heavily curtail the charging rate. We recommend no more than a rate of C/20 if you're charging below 0 Celsius. So it's imperative that you pay attention to this, these parameters. And one of the things that you can do to prevent your batteries from being in ultra low temperatures, remember this is the battery temperature, shouldn't be below 0 during a charging cycle. So if you just put your battery inside of an enclosure, and a battery as it charges and discharges gives off some heat. So that'll help insulate your battery. And ideally you could just install these batteries inside. And if you're installing them inside, you don't have to worry about the temperature range as much because typically internal temperatures are slightly regulated by the household. Our Simplify battery and Amplify battery, these batteries have advanced BMS units inside them. And the BMS unit can communicate with the charge controlling device to allow for an expanded temperature range. In fact, it actually does allow this battery to, on the charging side, to discharge at a reduced capacity all the way up to 70 degrees Celsius. So the scale is even more restrictive than what the batteries are capable of. Charging that, however, is regulated by the BMS unit with the communications. The communications inside the battery will tell the charge controller to reduce the rate of charging at low temperatures. And if you get to an ultra low temperature and you're still trying to charge, maybe you don't have the communications hooked up quite correctly, well, then the BMS unit can actually interrupt that charge cycle and go into self-protect mode where it will shut itself off automatically. So the communicating batteries are really a better choice for low temperature environments, and they communicate these charging parameters out to the charge controller. And if you have an appropriate charge controller or an inverter, that inverter will be able to receive the communications from the batteries. So an example is a solar or our inverter, our 6 kilowatt inverter. It will regulate the charging cycle. And so if you exceed these numbers that are given in this chart, the battery will self-protect and prevent problems. But this talk in this training is mostly around understanding the charge and discharge characteristics of the batteries. So these batteries must always be put in parallel, never in series, right? And so the Phi battery, this is a kind of a battery without advanced communications. It doesn't have the communications ability, but it's great lead acid replacement. It's great for people looking for a lower cost battery. You still get lithium, you still get 10,000 cycles, you still get 100% depth of discharge, unlike lead acid, right, where you might get 50% on a good day. You get 100% depth of discharge, you get an unlimited number of cycles, full 10-year warranty on this battery. But you have to make sure that you're using the battery under appropriate conditions. So it's got a C/2 rate. C/2 means the capacity of the battery can be, you can either drain the battery or fully charge the battery in 2 hours. That's what the C/2 rate means. So if your battery is at a 50% state of charge, and you want to know how long it would take to charge it up fastest, you would be able to top that battery off if it's at 50%, would be 1 hour, right? So C/2 charge and discharge rate can be translated into an amperage. That amperage is 37.5 amps for a 75 amp DC 48 volt battery. The 24 volt battery has got the same number of cells in it, but they're arranged different. And so it's actually got 150 amp hour capacity. And so half of that would be 75. Most people are using the 48 volt. And so a good rule of thumb is 37.5 amps per battery. If you've got 10 of these batteries in parallel, what would be the max continuous charge or discharge rate? 10 of these batteries. 10 times 37.5 or 375 amps. I'm not going to get into the smaller batteries that we have there, but remember the BMS is there to balance the battery and protect it from, it's really kind of just your end of the line protection. You want to make sure that you're programming the appropriate characteristics into your charging equipment. Let's talk a little bit about charging. Batteries use a variable voltage charging cycle, and the charging cycle starts off with, let's suppose we've got a battery and it's depleted and we're going to run a charging cycle on it. Sun comes out, it's early in the morning, the battery's at maybe a 30% state of charge, and what we do is we run a charging cycle, and the charging cycle looks like this. The first part of the charging cycle is what you see here on the screen. This graph is a charge, right, versus a current and voltage on the vertical axis. Over time, so at the beginning of the charging cycle, the first part says CC. It stands for constant current. Sometimes it's labeled I0 on manuals, but constant current charging cycle. And the number I just gave you in the previous screen is for a single battery, right? This single Phi battery or amplify battery, 48 volt, will charge at 37.5 amps per battery. So let's suppose we had 2 of those batteries, and we're going to run a charging cycle. So 2 of those batteries, 2 times 37.5. So we would set our charge cycle to charge at 75 amps, and it will go at a constant current. But as it's moving at a constant current, as it's charging up at a constant current, the voltage of that battery starts to go up. So at a 0% state of charge, we'd be at 48 volts. If we're at 50% state of charge, it'd be around 51.2 volts. That number depends slightly on temperature. So we're going to go constant current. The voltage is going to go up and up and up and up. the constant current part of the charging cycle ends when the battery hits the absorbed voltage. And so as that voltage rises higher and higher and higher, once it hits 56 volts, it will stop the constant current. So that 75 amps would just start being reduced. And so then we're going to go into a constant voltage. And so we're just going to hold at 56 volts. And the charge current is going to deplete and get less and less and less as that battery is approaching 100% state of charge. So for us, the absorb cycle is actually pretty short. It's just 10 minutes. So Simplify recommends a 10-minute absorb cycle. 6-minute absorb cycle. That's 1/10 of an hour, right? So 1/10 of an hour at 56 volts, that battery will be fully charged up. As soon as the charging cycle ends, what would happen to the voltage? Well, then the voltage is going to drop down from 56 volts to approximately 53.8 or so. That's a fully charged battery. Remember, the voltage that you're seeing on the battery bank while it's in a charging cycle is the voltage of the battery charger. And the voltage of the battery charger has to be above the voltage of the battery in order to get the battery to charge. So if we're charging off of a grid, we've got to be careful as well to make sure that we have the right charging parameters set. We want to have these voltage set points. These things are in our manuals. Grid charging, 56 volts, 6 minutes. That's the absorb part. The bulk voltage is set as a constant current. So if you take your battery's constant current setting, 48.5 for the Simplify, 37.5 for the Amplify and the Phi, you multiply by the number of batteries, you can figure out what the bulk charging cycle looks like. The absorb side is that higher voltage that you get to that you're going to only maintain for a short time. Make sure that your equipment offers the ability to program, and make sure your equipment is warranted for lithium-ion batteries. So we pride ourselves in having our batteries be good with lots of other people's equipment. Right? We don't specify what type of equipment you have to use, but make sure that it's programmable to fit the charging parameters of our batteries. Make sure it's lithium certified. You can also use external chargers to charge up a battery if you're in a situation where you need to. And we have a list of approved chargers in our manual, so have a look at that if you're interested in seeing them. Also, the BMS has built into these batteries a rapid shutdown protection. There's the circuit breaker is there, but also the BMS has shutdown protection in it as well, especially on the Amplify and the Simplify larger communications batteries. What does it look like when a battery is discharging? Well, I want to show you this graph. The voltage of the battery is different depending on whether or not it's operating loads. So let's suppose you have a battery bank, and that battery bank is used to supply loads. If you're starting out with a 100% state of charge battery, you'll start out somewhere around 53 volts, a little bit above 53 volts. This depends slightly on temperature. So if you go to higher temperatures, the resting voltage would be a little bit higher for 100% state of charge. Probably will never see it exceed, even at really high temperatures, you won't see it exceed 54 volts. Resting voltage means the battery's voltage when it's not powering a load. So let's suppose the battery was discharging and you'll see the voltage start to drop. So if the battery discharges by about 40% down to a 60% state of charge, that voltage will drop down from about 53.2. It'll drop down by a little over half a volt to somewhere around 52.5. Something about like that. And so that's the voltage you would see if you turned off the loads briefly. But if the loads are run, you would actually see a lower voltage than this. And so I'm going to try to explain that. I made a little figure on the right, and it's to kind of give us something to think about as the battery is discharging. So when a load is being powered, all batteries have a little bit of what's called internal resistance. This comes from the BMS, it comes from the battery cells themselves, it comes from actually the migration of the lithium through the battery cells. There's an internal resistance. So if the battery voltage is 52.4 volts in an open circuit condition, if the switch is closed and we're actually powering a load so that a current is flowing through this circuit. Sorry about that. I've got my phone ringing here. If you're powering loads and you're running current through this circuit, then there's actually going to be a voltage drop inside the battery. And so I'm going to try to illustrate that with the next screen. So what I'm showing you on this screen is resting voltage. The next screen, where you're going to see, this is when you're actually discharging a battery. And excuse me, I'm going to have to mute this. Sorry about this. Okay, so sorry about that. When you're discharging a battery, so when you're in a discharge cycle, you're under load, the actual voltage is going to be what it would be in a resting condition. So I just showed you in the previous screen what a resting battery voltage looks like. Notice that at 70% state of charge, we're still above 53 volts. Well, look what it looks like if we're discharging this battery at a slow rate, a C/5 discharge rate. So at a C/5 discharge rate, right, when we're down at 60% state of charge, we've discharged by 40%, we're actually down to 52 volts. And if we're discharging even faster, the voltage of the battery would read below 52 volts. And if we're discharging at a rate of C/2, the max discharge rate of the battery, we're going to be even half a volt lower than that. So we're going to be down at 51.5 volt. The reason for that is some amount of voltage is lost across the internal resistance of the battery. The rest of the voltage is, of course, across the load, whatever that load may be. Most typically, it's your inverter. So keep that in mind as you're looking at the state of charge of a battery. It depends on whether or not you're powering loads. So if all of a sudden you turn your inverter off, you'll see the battery voltage rise up, and it would rise up to the resting voltage of the battery, which is shown on this curve. That being said, this curve is fairly accurate, but this is maintained. This was obtained at a 25 degrees Celsius temperature. There is a slight variation in the discharge cycle of a 48 volt. This is a 48 volt LFP battery cell being discharged under different temperature considerations. And you can see that the voltage varies versus temperature. And if the voltage varies versus temperature for a single cell, then it does for multiple cells. And so you'll see there's some slight temperature dependence. But keep in mind, these are drastically different temperatures. -18 Celsius, you're going to get a lot less energy out of your battery, and you really should be discharging it slowly at that temperature. So the actual voltage of your battery at a given state of charge is not easily obtained unless you're in a resting state. And so if you really want to check the state of charge of your battery just based on voltage, you've got to be in a resting state where you're not powering loads. So let's talk a little bit about the 5 battery discharging characteristics. We want to not exceed a C/2 discharge rate. The maximum continuous discharge rate for a 48 volt battery is then 37.5 amps. That works out to the battery discharging in 2 hours. So if you have a 3.8 kilowatt hour battery, that's the capacity. The power output of that battery would be, you would be discharging at 1.9 kilowatts. So you're using up power is the rate at which you're using energy. You're using up half of that battery in an hour maximum. And so if we look at the current rating, it's a 75 amp hour battery. Half of that is 37.5 amps. So that's the maximum discharge rate per battery. And remember, you can have multiple batteries in parallel. And so if you have 4 batteries in parallel, the maximum discharge rate is multiplied 37.5 times 4. And it varies based on the voltage of the battery, but most people are using the 48 volts. So I'll let you look at those examples if you are using a different voltage. The discharge characteristics, if you're surging the batteries are capable of surging. So a 5 battery is capable of surging at 80 amps for 10 minutes. And that's pretty close to 2 kilowatts when you're discharging for just 10 minutes. But if you discharge too long, remember there's an internal resistance inside the battery, and the battery starts to build up heat. And so if you discharge at really high rates for a long time, the battery can overheat. You can use inline breakers for protection, and some people do incorporate DC breakers into their systems. The battery, of course, does have a 100 amp DC breaker built into it, but that's not a fail-safe for regulating at the appropriate continuous discharge rate of 40 amps. So you have to pay attention to that. So some people will install inline breakers for an extra level of protection. I'll talk a little bit about breakers in a minute. You want to size your breaker based on maximum continuous discharge. I'll show you that. So let me give you an example. If you've got an inverter that's maybe an 8 kilowatt inverter, but you're trying to run it off of just a few batteries, you have to make sure you have enough batteries there to power that inverter. So each individual 5 battery is capable of 3.8 kilowatt hours. It's at 48 volts. And so if we have 2 batteries, right, then we would be able to get about 3.8 kilowatts out of that battery bank. As an example, a max discharge rate of 37.5 amps DC per battery module means that we could get a maximum continuous discharge of 75 amps DC with 2 continuous, 2 5 batteries. We would recommend a 60 amp breaker for this. Let's talk a little bit about why. Well, let me get into why on the breakers. Breakers do not necessarily trip at their given amperage. So let's look at a breaker and let's look at a characteristic. So each breaker, each DC breaker you buy would come with a trip curve that looks something like this. Notice that at 100% of the load, this particular breaker will never trip. So at 60 amps, this breaker will not go off. It's not until you exceed that this breaker trips. And the amount by which you exceed that, so if you go to 120 amps, 200% of the load, it still will take 10 seconds to trip. This is a slow trip breaker. At 150% of that load, so 90 amps, this breaker would take 20 seconds to trip. Hopefully I said 10 seconds, 20 seconds to trip at 150% of load. And so notice that each of these breakers has a trip curve, and you'll want to pay attention to that. At 100% of this rated load of 60 amps, this breaker will trip in a little over a second. So not all breakers are equal, right? You have to pay attention to the trip curve of breakers if you're going to be using them in your system. Here's an example of an A&L fuse. This fuse will not burn, right? So what happens as current passes through a fuse is the fuse has a resistance to it and it gets hot. If it gets too hot, it melts. So this particular fuse will only burn out if you're at about 90%, or sorry, 150% at load or 90 amps, and it will still take 10 seconds to 20 seconds to burn out. So keep those in mind if you're going to use those. When you're looking at the discharge of a battery, there's a particular place in that discharge cycle that we call the knee. And you really have very little energy left after you've discharged a battery to the knee. The voltage drops rapidly and there's very little state of charge left. You're looking at close to zero by this point. We recommend not discharging below 20% state of charge for the greatest longevity of your battery. So we know that when you discharge your battery, you don't always discharge it the way it would in a lab. But if you take a battery, you discharge it only to 20% state of charge. So that's 80% depth of discharge. And you do that again and again and again. You can do that 10,000 times, right? Approximately 10,000 times for a LFP battery, one of our LFP batteries, which would last for, as I said, 27 years. If you're discharging down to 10% state of charge, that number changes to 6,000 cycles, right? So you're only looking at more like 15 years if you discharge every time to 90% state of charge. Discharging to 100% depth of discharge, you're really only looking around 3,000 to 3,500 cycles if you cycle all the way down to 48 volt every time. Discharging to 48 volts 100 times is not going to cause major problems, but batteries are most vulnerable at their greatest depths of discharge and their highest states of charge. So high voltages on the battery when you're in a charging cycle are the dangerous parts, and then discharging beyond the rated voltage of the battery. So you don't want to discharge your battery below 48 volts. And even if you continuously do that, if you are having equipment that drops your battery below 48 volts, it can even void your warranty. So pay attention to these settings, your low battery cutout on your inverter. I recommend that you set your low battery cutout for a daily cycled battery to a 20% depth of discharge, which will be around 49.5 volts. And 10% state of charge or 100% state of charge if you're really only using it for battery backup. So let's get into the state of charge side. Resting state of charge, remember I talked about that being different from a loaded state of charge. And so the voltage varies depending on what load might be there. You can use external monitoring equipment. Shunts are common examples. Victron BMS 712 is a nice battery monitor if you don't have it built in to your charging equipment. Our amplified batteries even allow you to hook up a gateway. New Sun Road makes a gateway that allows you to hook directly up to our BMS battery and gives you information at the battery level. So it can tell you all the information, the state of health, etc., temperature. You can pull a ton of information out of our batteries if you're using a communications enabled gateway or inverter. So again, here, these voltages are here to give you an approximate idea when the battery is resting, what the state of charge is based on the voltage. So if the battery is resting 49.5 volts, it's only got about 10% of its capacity remaining. If it's resting and you're at approximately 51 volts, then you're at a 50% state of charge. By the way, these are typical these are typical for a C/2 discharge rate, not for resting. Resting was in the table and the numbers are slightly higher. Apologies. So let's have a look at what that would look like. What that would look like when we're under a discharge cycle. So under a discharge cycle, notice that we start off at a higher voltage, and that as we're discharging, we're discharging our battery, the voltage is dropping. But if we increase the rate of discharge, so we're discharging at a C/3 rate, that means the battery would drop by 100% in 3 hours. The number is less, right? And if you're discharging at a C/2 rate, during that discharge cycle, again, I showed you this curve before, but your voltage will be approximately 2/3 of a volt below a C/5 discharge rate. So keep those in mind. I want to mention a bit, we're kind of getting towards the end of the material. I think I'm going to skip this example, but I want to mention a little bit about our Elite IQ installer program. So we are, as I said, going to be at NABCEP, but we're also running a promotion right now just until the 31st of this month. And if you are an installer or an installer company and you want to get your company registered to install simplified batteries, it's something that we can do in less than an hour. If you sign up for Elite Installer Qualification Program, we've got a $1,000 bonus right now. We hadn't done that before. It's a pretty huge bonus for us. We've got a lot of companies that are signing up right now. And so again, this promotion ends on March 31st. So you need to complete your application on our website by March 31st. And the link, I'll show you where that'll appear in a minute. I'll also be sending that to you when I send you these slides. So the Elite Installer Program, there's a link right here to sign up. If you fill this form out, it's a fairly short form. You fill that out, we'll contact you and you go through a short amount of training and you can get registered with us as an IQ installer. There's actually, this is our website, and I did want to point out to you that a lot of this information that I'm giving to you is available in our installation manuals. We also, if you're installing our batteries with other people's equipment, suppose you're installing a Schneider or a Solarc, etc., we have integration guides that tell you basically how to use that equipment and what settings to put in for their software. So a lot of people actually contact us when they're installing a solar and ask us for help on programming. The integration guides are here on our website. It's a really helpful feature. Additionally, because we're running that promotion, there's an additional button up here that tells you how to sign up for that $1,000 promotion right now. So I want to thank you for your time. I'm going to jump into the Q&A right now. So if you've got a question, if I didn't do a good job of explaining things, let me know. I'll clarify right now. If you're here for NABCEP credits, then please send an email to training@simplifiedpower.com. Let me know that you attended. I'll verify from the attendance logs that you participated, and we'll send the NABCEP certificates. So the email again there is on the screen, training@simplifiedpower.com. I'm going to jump into the Q&As. So Kuno, you asked about why 24-volt batteries might appear at 26.1 volts out of the box. They come discharged, and the reason that they're shipped discharged is there are regulations around, UN regulations around shipping batteries. They're not supposed to be at high states of charge. It makes the batteries safer to ship them at a low state of charge. Unfortunately, we can't top them up for safety reasons before they leave the factory. International warranty, yes, we have warranties on our batteries internationally, and they apply in the same way. We've got a lot of installs around the world. Puerto Rico, Mexico, Australia, Spain, Europe, Africa. We've got a number of certified installers in Africa as well. Thomas writes, what information does the battery exchange with the inverter? For example, a Solarc 15K, how does the closed loop communication interact with a virtual power plant? I don't know a ton about the virtual power plants, Thomas. I'm going to be honest. If you want to know more about that, send an email to training@simplifiedpower.com and I'll connect you with the right person. But the battery exchanges a lot of information with the inverter. So typically the most prevalent information is about the temperature of the battery and what charge and discharge rates the battery wants to see. And it's sending this information every second to the inverter. So it's not like it does it once an hour. It's constantly telling the inverter, hey, my battery temperature is at this range. Don't discharge me faster than this, etc. It sends the state of charge information, sends the voltage, it sends the temperatures of the cells, which allow the inverter to calculate state of charge, right? Remember I said that state of charge, the voltage depends on the amperage out, as well as the temperature of the cells. And so if you want the inverter to properly understand the state of charge information, it sends all of that out as well. And so if you want accurate information out of your battery bank, a communicating battery would be the right thing to use. So hopefully if I answered your question, I don't know about the virtual PowerPoint part. Wacas Deloire asks, what chemistry is best for large scale backup, like 500 megawatt hours or greater? Wow, that's greater than the total amount that Simplify's installed worldwide. And we've installed thousands and thousands of batteries, tens of thousands of batteries. So at a very large scale, some of the Tesla systems have been using NMC. Tesla and I'm trying to think of, I guess, Lucid have both been switching their cars over to LFP. So LFP is a good option for installing at the utility scale. You would just use high voltage battery racks. So you want to install a higher voltage because then that means less current, and current is where you're losing your losing more of your power to the generation of heat. So high voltage stacks at the utility scale. And then I don't know if you guys know about this, but a little bit of trivia. You know, there's a professor out of MIT who has worked on a liquid metal battery, and forgetting the name right now bothers me. I can't remember the name, but liquid metal batteries are also potential for large scale. Of course, you wouldn't want a liquid metal battery. You'd have to be at really high temperatures to have that. You wouldn't want a liquid metal battery in a small application. But for large scales, they might make a lot of sense. LFP as well, right, are good options for large scale. What is expected life of these 3.8 kilowatt hour batteries? So under optimal conditions, that means you don't have the battery rained on, you don't have high levels of humidity. 25 years is an expected life of the 3.8 kilowatt hour batteries. 25 years is a long time. That's 9,000 plus cycles. So we expect our batteries to last 10,000 cycles. Are 12-volt batteries rated for the outdoors? No, the only outdoor rated battery they have that doesn't need an enclosure is our Simplify 4.98 kilowatt-hour battery. We offer enclosures. And yes, Wakas also asks, are these are LFP? Yes, all of our batteries are LFP. And we use a high performance cell, a high quality cell. Can you please provide these slides? Absolutely. I'll be sending the slides to all of you, as well as a link to see if you're interested in signing up for that authorized installer option that we have. Has Simplify created a 48 volt? So this is an anonymous question. Has Simplify created a 48 volt, 120 volt, 48 volt DC, 120 volt AC 3-stage battery charger for off-grid applications with 120 volt generators? No, we haven't created our own, but we do have one that we can recommend. And you're asking for the recommendation on that. So I'll send a link. I think I'll send it to everybody with our with these slides to some chargers that we recommend. David asks, given the low temperature storage considerations of 6 months and 3 months between higher temperatures, how might, between extreme temperatures, how might seasonal fluctuations between the two ranges impact the safe storage length? For example, I have a cabin in Northwest Ontario that is not heated. During the winter months, the temperature will sometimes go below -25°C, but not continuously. Does the 3-month storage limit apply if at any point the temperature drops into that range? I guess the answer, David, is kind of gray on this, right? So the answer is these are recommended storage limits. And so probably I would say yes, but if it only drops there a few times, then no. I mean, if these storage recommendations are based on laboratory tests, right? In a laboratory test, you keep the temperature at -45 continuously. I understand that real world applications have variations in temperature. So I think that the gray area here is that your recommended temperature or your recommended storage length for variations in temperature that hit both the extremes and in the normal conditions would be somewhere between 3 and 6 months. I hope that makes sense. And if you're going to store much longer than that, you want to charge up the batteries, particularly if you want to have the battery breaker switched off during these storage conditions, because otherwise the BMS can use some of the power. Wakas asks again, can I get these slides? And the answer is absolutely. Ben Rogers asks, Ben Rogers asks, how long do you have to wait after discharging to consider the battery at a resting state? Not at all, Ben. The resting state of the battery is as soon as you turn that charger off. However, the temperature of the battery as soon as you turn that charger off will be a little bit higher because it just went through a charge cycle. And so you might see, even though the battery is not being used, you might see that the voltage come down just a little bit, maybe 0.1 to 0.2 volts after the battery has started to cool down. David Harris asks, is lifetime battery health determined by fully charging the battery and then checking resting state of charge and comparing to the expected voltage? For example, if the battery receives a 90% full cycle charge, but then is resting at what would indicate 90% state of charge, does that mean you have lost 10% of the battery life? Not exactly, David. So good question, but not exactly, right? So what happens as a battery ages is that the internal resistance of the battery can go up as well. So it's not just a voltage, it's also an internal resistance. So if you want to know the real health of your battery, we can recommend a capacity cycle. So what you'll do is you'll charge the battery up to 100% state of charge at a given temperature, and then you'll discharge that battery under a C/5 discharge rate. And we'll look at the capacity that you get out of that discharge cycle. Tom says, thank you. Michael says, you're welcome. Michael says, do you have discharge graph curves for 24 volt you can share? I think so, Michael. Can you send me an email at training@simplify power? Let me scroll back to that email address. training at Simplify Power, and I will get you the discharge characteristic for a 24 volt. The answer is it's exactly cut in half. So if you look at the 48 volt one I shared, cut it in half, that would be a 24 volt. What is 80% depth of discharge for a 24 volt 3.5? So answer is for, it doesn't matter the capacity of the battery, the voltage of the battery. So 80% depth of discharge, you could take the curve that I gave or the table I gave, use 48 volt and cut it in half. But again, if you send me an email, Michael, I'll send you the table and the graph that you're requesting for 24 volt. Kuno asks, so why can I see 26.1 when the battery is only about 20% state of charge? Let me go up to a charge cycle for you, Kuno. Looking for that table. I'm missing the table. I'm sorry, I'm not going to be fast here. So let me do, I think it was here, but it was, I guess I can't find it right now. All right, so for a resting battery, I'm just going to show you the graph. And for this is under load, for a resting battery at 26 volts would be half of 52. So if I go to 52 out here, and I'm looking at, I take half of that for a 24 volt battery, right? You would be about 25% state of charge, right? You're pretty close to the 26 volts that you're mentioning. So I'm saying it's 25% state of charge. You're telling me it's 20. So please clarify if I'm not answering your question, or send me an email, or even contact us. So again, Kuno, a 24 volt battery is not really 24 volts. That's kind of the lead acid equivalent temperature or voltage rating. Russell says, Xcel Energy is requiring our church to guarantee that we will not charge the 12 batteries we are buying from the grid. Why does that make sense or not make sense? So Russell, I think the probably whatever program you're participating in with your church is asking you not to charge from the grid, because they're asking that you're recharging from a renewable source. Some programs offer tax rebates for installing battery backup. And the reason is that this helps the power companies to kind of stabilize the grid, so that you're kind of discharging your renewables back into the grid, and the batteries that you have are preventing you from drawing during those peak times. Hopefully that answers your question. If not, feel free to ask again. We've got a number of more questions. So I'm going to try to get through all these. There's 38, and I know that most people are kind of eager to finish. Nova asks, does it work with microinverters like Enphase? Yes, with the appropriate. So Enphase produces an AC off of the solar panel. So as microinverters mount to the solar panel and produce AC signal, you need an inverter that's capable of handling AC to invert that to produce DC to charge a battery. Our inverters do it. SolarArc inverters do it. A number of inverters are capable of doing this. So yes, our batteries can work with Enphase. Anyone who's working with a virtual solar company from outside the US can recommend Simplify batteries. I think you're asking, because I'm happy to put you in touch with our projects team, and they're doing a lot of projects around the world. We've got a very large project in Sierra Leone right now, where we're doing, I think, 65 villages there. So send me an email and I'll put you in contact with the right people that can kind of give you some testimonials to our larger projects. Jorge asks, are any integration guides for NG? Do we have any for Enphase microinverters? I think, Jorge, that I'm gonna, or I think it's, I've got your name wrong, it's Jorge. If I think the IQ8s prevent communication with So that's the latest N-phase release, prevent communication with some charging equipment. And so if you're using an N-phase IQ8 microinverter, I would recommend you stick with N-phase batteries because they pair well with the IQ8s. N-phase is trying to be exclusive in a way, kind of like Apple, right? So we do have integration guides, I think, for Solar Edge inverters. So check our website for that. Michael writes, I have 4 24-volt, 3.5 kilowatt-hour batteries charged by 2 Outback charge controllers that SCADA isn't working with. So one charge controller is run without visibility. Initial settings for the rate were set. Do I have to be concerned that the charge controllers no longer communicate about rate of charge? I think that's a good question, Curtis. I'm going to let you contact our technical support and actually bring that up. I'm not sure why the monitoring equipment from Outback is not working with them. We deal with Outbacks a lot. There are some problems with some lines of Outback charge controllers, which unfortunately they haven't been recalled. So why don't you contact our tech support and ask directly about your charge equipment. I am a little bit concerned that you're not being able to monitor. David asks, does storing a battery and therefore not cycling it for months at a time further extend the 25-year life expectancy? Is life expectancy based purely on number of cycles, or is there a time component that imposes realistic limits? Great question, David. And the answer is yes. Environmental conditions matter. So all batteries, all of these cylindrical cell batteries have a vent in them. So they're hermetically sealed, which means they're sealed. But they're inside a steel case, and the vent is there in the case of high temperature, high pressure. So when the pressure builds up to about 10 times atmospheric, that the pressure would build up even higher than that. And so when the pressure gets that high, that vent opens up and they off gas. The vent and battery case itself is susceptible to rust. So we have seen cases, we have a battery that's recently come in that saw salt spray, right? And so the case rusted, and with time, water was actually found inside the battery. And so environmental considerations can lead to rust. These batteries are sealed fairly well. But you can't have them immersed in water or even have them continuously rained on if it's not an outdoor rated battery. So yes, environmental considerations like humidity, especially if you live near the coast like I do. I live near the coast here in California, and the humidity in the air actually contains salt, which can reduce lifetime as well. If you had a battery in controlled conditions, meaning a battery without moisture in the air, etc., it would mostly be based on the number of cycles. Good question though. Russell says, if our batteries sit on a shelf or a shelf from the distributor, they will be discharging. How should we calculate the rate of shelf life discharge so that we do not wait too long to activate the system and start charging the batteries before they go through something special to get the batteries up? Okay, so before we have to go through something special to get the batteries operating. So Russell, a good rule of thumb is for our lithium batteries, as long as the breaker is switched off, they discharge at about 1% per month. So they have a pretty long shelf life. It's just that we have to ship them at a 30% state of charge. And so at 1% per month, we recommend kind of topping them up every 6 months. But batteries can sit a lot longer if they're starting at higher states of charge. Typical float charge amperage. We don't recommend floating the lithium batteries because they have such a low discharge rate. But if you have a renewable energy source, you can float at a 54-volt voltage, and that float charge amperage will vary based on that voltage as the battery reaches closer to 100% state of charge. But less than 1% of the amperage rating of the battery is the typical float charge amperage, and it's really based on voltage. So if you are going to float from a renewable source, float at 54 volts for our batteries. What is the issue why lithium batteries can only work down to -4 degrees Fahrenheit? James, good question. Inside all batteries, and I don't have the slide here for it, but inside all batteries is what we call the jelly roll, and a jelly roll is kind of a sandwich of a cathode and anode, the positive and negative sides of the battery, and that contains a solution called electrolyte. And the electrolyte is contains lithium ions as well as well, there's some negative ion as well, which is typically PC6. But what happens as you get really low temperatures is that the salt solution, like you have very low, the ions are moving very slowly. And because those ions are moving very slowly, you have high internal resistance. And so you have to apply a high voltage in order to get those ions to move quickly. So those are kind of the limitations are based on the mobility of the lithium ions at very low temperatures. Let's see, I'm hoping I didn't skip some. So next question, Rob, I have older cabinets that are black. I assume it's just a color change anyway. Yeah, we did change our color to white more recently. It absorbs less sunlight, right? I want to add 4 more units. Are the new batteries going to be depleted due to the age of my 4 other batteries? These are, so it depends, typically beyond about 4 years, unless you have a really large battery bank that is not heavily taxed, meaning that you're not using the battery at a high C rate. We don't recommend adding batteries beyond about 4 years. So contact our engineers and they can give you a recommendation on how to add more units. If your batteries are just a few years old, then no big deal adding batteries to the bank. Once the battery is dead after 25 years, is there a recycle program? Yeah, absolutely. Oves, there's a recycle program already. You can recycle these batteries, and because these batteries don't contain cobalt, they're more easily recycled. So if you're interested in learning more about battery recycling, check out Redwood Materials. It's a former Tesla employee that started a recycling for battery program. James writes, how well tested are the heating pads for the batteries that you sell? If the battery is an Amplify battery that turns off to cold and then we'll power the heating pad. Yeah, so we sell heating pads that sit underneath the batteries that run off of the battery itself. And so they're wired into the BMS. They are special order, but they're good for operating in low temperature environments. So we had the discussion recently, right? So whether or not you need it with an Amplify battery, the reason you might want to add it with an Amplify battery is typically the batteries might be cold in a low temperature environment early in the morning, but your charging is there early in the morning from solar, right? So if you want to start, my recommendation is if you want to start your charging cycle early in the day off of solar, you would want to add a heating pad or at least an insulated cabinet so that as soon as the solar is there, your batteries can start charging it at quick rates so that you're using as much as your solar as possible. They're very well tested. We sell a lot of these heating pads and very rarely have them come back. Wakas asks, do we have any documents, guidelines regarding battery ESS systems for design for large scale projects? Absolutely, Wakas. Again, email me and I'll put you in touch with our high voltage large projects division. Richard Fryer asks, your batteries are made in the US, but are the cells themselves also manufactured in the US? No, Richard, our cells, we've used the same supplier for a long time. Our cells are made in Asia. The only company making battery cells in the US, to my knowledge, is Tesla. But again, we've had a long-standing relationship and testing relationship with our cell supplier, and we're using premium battery cells. The rest of the battery parts, the BMS, the casing, that is manufactured and all the assembly is done in Oxnard, California. So good question. Is a span panel communication possible or on the horizon. We are in communication with SPAN and some others, and even, yes, I have to leave it there. We are in communication about load control. Why did they change from a plastic case to a metal case? Many people still prefer the plastic. Well, actually, good question. We can actually produce the plastic case still. So if you're interested in an ABS case, we offer that as well. What temperature do you recommend for better health and long life of these batteries? These batteries operate very well in the temperatures from 25 to 40 degrees Celsius. It's really the humidity in the air and other factors that influence the life. If you're in a low temperature environment, consider reducing your charging rate. The charging rate can influence the lifetime of the battery, because what happens is the lithium can start lithium plating on the charge cycle, because the lithium can't get into the graphite layer, and so it slows down. Philip asks, when in a foreign country, please send the best number to get directly to tech support, which includes an area code and not an 800 number. I'll give you that phone number right now. It's 805-640-6700. Extension 1 gets you in touch with tech support. So, and if you're international, and yes, we do have WhatsApp. I have WhatsApp on my phone, and we communicate with people from tech support through WhatsApp. So if you're calling internationally, you're going to dial +1-805-640-6700, option number 1. And there's no hold. We don't have an answering service. It just comes directly to us in tech support. So thank you, everybody. I got through 40 some questions there, 45 questions. I hope I answered your question. If not, please send me an email. And once again, the email is on your screen. So thank you very much. Hope you have a good day. Bye.